Hello everyone, a very good morning to all of you. In the second session of this DBMS course, we'll be learning about the entity relationship model. What it means is whenever we are analyzing or building some database or building some tables, especially at the large set, we have numerous values. Okay, so numerous tables, numerous data sets, and all of that has numerous data sets. So for all these, clustering all this in the most appropriate way so that the results come in an optimal manner in the lowest possible time. We need to categorize the entities and the attributes. What are the most important things which are able to cluster or categorize all the data available? Like if you are booking a flight ticket, the flight, this your ID becomes the most important. Okay, so there are certain attributes like this is your user ID, okay, your name, your age, sex, and all the other details. All of these comes in a single part as a user. So I'll build a table user there, and I'll make all of it as different parts. All this becomes attributes. All this becomes attributes. Okay. These are the attributes within the table user. So likewise, I'll call this user as an entity, and then I'll build all the different characteristic features of this user as an attribute. Like that I'll understand, like that I'll categorize or analyze the table, and like that exactly all the things are programmed in SQL. That is very important. Okay, exactly like that they are programmed in SQL. So whenever all the entities are there, like user, now he is booking the flight ticket. So likewise the flight. Alright, so this is the entire concept. Okay, let us proceed further. Now see the table here. This table, this data, all this data. Okay, this data like all of them are the different table column this column headers. Okay, each of it I'm calling it as a single attributes. So somebody can think why not it is an entity. Okay, there's normally a difference or normally some confusion coming in the users, or how to categorize something as an attribute, something as an entity. Understand that all of these customer IDs, customer name, customer street, customer city, account number, all five of them belong to the person customer. Okay, so if I build a table customer, okay, like that is the done most important part. So that customer becomes an entity there. Okay, that becomes an entity. So whenever I have the table name, I'm normally the putting this customer table name when I'm storing it there is also the entity when I'm building such diagrams. Okay, understand that. So customer, this part becomes an entity, and all these five things becomes the attributes. Like that, the things are worked out. Okay, understand that. So now this has different values. Five values are provided. Like that, this table will be there. So there are attributes and entities. Entities most important part, like which are able to cluster several data together. Okay, these entity names are normally the table names also. Alright. Now understand that whenever you are calling or we are extending the discussion further, all these tables are just the collection of entities and just their attributes, set of all the entities and attributes. So now see the definition here. An entity is an object that exists and is distinguishable from the other objects. You are able to properly categorize it itself, that this becomes an entity. This is able to cluster several things. Okay, so for example, specific person, company, plant, event, all of this comes in examples, these entities. So a person can have multiple different characteristic features, okay, characteristic values, age and other things. Company may have all different things, what is its type, what is its production, how many employees are there. So different attributes can also be there for the company. For the event, what category of event, how many people were there, okay, how much budget was involved. So like that, different attributes could be there for the event as well. For the plant, okay, the plant also, like what was the plant, okay, which is the vegetation type, where it is grown, okay, how much soil, what kind of soil it requires. All of this becomes the different attributes. So all these parts, the attributes become the characteristic features which are able to properly describe the entity. Like that, the thing is there. And exactly the same concept is used to categorize the entity and the events attributes properly. Okay, so the entity set, when I'm calling it entity sets, okay, is the set of entities of the same type that share the same properties. Okay, so same type, same properties. Like rather than one customer I'm putting it like customers. That becomes a set of entities. Okay, entity set. Okay, hotel is one entity, but when I am calling it as hotels, okay, so that becomes the set of entities of same type with same attributes, same thing. Okay, the values may be different. We are not bothering our own values, but like that you will understand the things. Okay, or like that the things are modeled in the database. Now see, the loan number and the amount. See, I'm showing two tables here, customer and loan. Two tables like that, they are entity sets. Okay. Both of them connected to the similar customer. Alright, so now understand how to extend our discussion further from entities, attributes on all these tables in the database, especially to build the database tables effectively. Understand that every table has got some strong entities and weak entities. When we say strong entities means they are a most important part. Without them, the things will not work. Okay, like everywhere, like even if I don't ask your address, home address or your like working address somewhere, it may work. Okay, because I have your like unique some ID or some mobile number or things like that. So the most important things I put separately as strong entities. But the weak things which are not always needed, I put separately. Now understand what is the advantage? Okay, so a weak entity is a type of entity that does not have its key attributes. It is always dependent on the strong entities, without which it is meaningless. Okay, so it can be identified uniquely by considering the primary key of another entity. Now see the term primary key here. Okay, primary becomes the most important word. Primary means the most important attribute of the strong entity, without which it cannot be recognized properly. Okay, like in your bank account number becomes the most important attribute. If I have your account number, bank account number, I can recognize all the details, I can retrieve all the details. But from your name, I may get duplicates. Okay, so that is not a unique thing. That is not a that is not a primary key. So primary key means within the strong entity, the most important attribute is called as primary key. Understand properly. Within the strong entity part, whatever is the most important attribute, it is called as primary key. Okay, like that. So weak entities are always dependent on this primary key. They are connected like that. So if a strong entity has table has seven columns, okay, seven attributes. Like weak entity has four attributes, which are weak, which are not always needed. These four attributes tables are built in correlation with the primary key of this strong entity table. So whenever we are writing, I will always write the four columns of the weak entity plus the primary key of the strong entity. So because by that primary key, I am able to recognize what is it all about, what these values are all about, how they are connected. Okay, I'm able to get the integrity of data properly, no errors at all right. So these are the major differences. A strong entity always has a primary key, the most important attribute, but weak entities do not have enough attributes to build a primary key. It cannot be discriminated on its own. It is always dependent on the primary key. Okay, so when I'm building the diagram, all that diagram is called as entity relationship diagram, ER diagram. Entity relationship diagram, ER diagram. Okay, through this, even the complicated relationship among like several different tables, several different attributes can be just like properly plotted, and this becomes very useful to minimize the redundancies, okay, and able to like do the things effectively in an optimized manner. Okay, this is the primary key, the strong entry part. It is represented by a rectangle symbol. Okay, strong entities. The weak entity set is represented by double rectangle. Double rectangle, one rectangle encapsulated within the another rectangle. So primary key is one of the attributes which helps to identify its members. It is the most important attribute. But in the weak entity set, it is a combination of primary key plus partial keys. Okay, all the other things. Okay, they are as such. If I am getting the weak entity set, I am unable to discriminate which these entities belong to, or how these entities belong to with what. But if the moment I get a strong entity set, the primary key, I am itself able to recognize everything. That the weak entity set is connected there. Alright. See, now understand this diagram. Okay, this is just a basic entity relationship diagram. Here I am putting a customer. See the part customer, I am putting a rectangle. And this is a double rectangle, loan. Loan is a weak entity. Reason, every customer does not take loan. Okay, so loan is just not a part. Whenever it's needed, it's there. So this becomes a weak entity. But the customer is a strong entity. Okay, everywhere for bank or the big shopping malls, everywhere. It has customer ID and customer name. Suppose two attributes I'm putting. So now tell me what is the most important attribute which can be like properly uniquely recognized. Uniquely recognized. This is customer ID. Well, customer name can be duplicates. Okay, we may have like multiple customers of the same name. Okay, the customer ID becomes a unique thing. So this becomes the primary key. Okay, and this is a strong entity. Strong entity is their customer, for which the primary key is there. Okay, like that. But this is the weak entity part. Okay, and then the double rectangle. Here, like loan name, loan date, and other things, loan type, these details are there. And the customer is borrowing a loan. Now see the relationship between these two entities is recognized. If it is meaningful, Well, the strong entities are mutually connected. I keep it in rectangle. The simple one part. Okay. But if I'm two diamonds, I'm putting, these are normally called diamonds. Okay, diamonds. If I'm putting a single diamond, this means two strong entities are connected. But if I'm putting two diamonds, this means these encapsulated two diamonds is a link between strong entity and a weak entity, as it is represented here. Okay. An employee has dependents. My family members are not directly associated to my company or my university. Okay, but so they are my dependents. So they am, whenever the university is plotting the part, whenever they are asking me the details, that is the part of weak entity. All the dependents, every detail about dependents comes in weak entity, which are connected with the my employee ID. Employee ID becomes the strong. This is the primary key of my the strong entity employee. So strong entity employee has the primary key employee ID. Like with this employee ID, I can call all the dependents. All right. All right. So now see the six different diagrams which are normally used to build our ER diagram, entity relationship diagrams to show the relationship between different customers, different attributes are normally built using these six diagrams. Here the entity, see the part, entity of the strong entity is termed like this, single rectangle. Single this diamond is showing the relationship. Likewise, the double rectangles shows weak entity. Okay, so which are always dependent on the strong entity. Okay, or the primary key, most important key or most important attribute of the strong entity is always defining the weak entities. Always remember. Okay, so and these weak entities are connected to the strong entities in the diagram by using a weak relationship in the double diamond. Now when I'm putting the attributes, all these attributes within the diagram are represented like this. Okay, single ellipse attribute. But some attributes here, see, are normally multi-valued. Multi-valued means, suppose your mobile number, house address, okay, all these parts, all these things keep on changing. We may change. Okay, so these things, these values, especially these attributes, especially may have multiple values. Okay, so they are allowed. So these special attributes are represented like this. So whenever you are building a diagram, you should properly note that these attributes are normally multi-valued. So I should put it in this double ellipse. But suppose the date of birth is there. Date of birth cannot change. Okay, so it's a single ellipse. Like data attribute. Alright, let us see an example here. Suppose I'm putting the ATM here. ATM, I'm putting ATM ID, address, time. So for this strong entity ATM, which I'm putting in single rectangle, what is the most important attribute? ATM ID, address, time. What is the most important attribute? It is ATM ID. You are thinking rightly. By this ATM ID, bank can easily recognize that this ATM is located there and has this much account balance. Alright. So this ATM now has the weak relationship transactions. What all transactions it doing daily? Okay. For us, the ATM amount is important. Okay. For bank, this is important. Bank is not bothered about the transactions. That will be itself taken care. But these transactions are there. All these attributes I'm showing. But all these attributes are the simple attributes, no like multiple amounts, multiple values. Okay, amount, transaction, amount, type. Okay, all right. Now let us see this further. The attributes types. Multi-valued we have been discussing. Okay, as it is shown here, multi-valued attribute student details, especially the address. But these attributes are normally kept simple, which cannot be divided. Like your phone number is there, I cannot divide it into two. But suppose your address is there, they can divide it into house number, your plot number, okay, or the area, okay, the property like locality or the district, the pin code. I can divide it into multiple simple similar attributes. Okay, so such things comes as composite attribute, or your name is there. Okay, your name can be distinct, like represented as first name, middle name, surname. So okay, so the name can be a composite attribute having three individual words: first name, middle name, surname, as you have seen in different forms. Okay, but some attributes are derived attributes. So what do you mean by derived attributes? They are normally not there. They are never asked. Like suppose our age is there, is never asked. The everywhere in the programs, the system itself calculate from our date of birth. Likewise, if they are asking you the pin code, they don't ask you the special like state or the thing where you are living. They don't ask. Or suppose our working place asks us the pin code. That's enough to describe which locality we are working. Okay, so some things can be like completely described with some other attributes. Okay, so they are derived attributes. Okay, now see the composite attribute, the example. See, this part I already told you, name, first name, middle name, last name, the composite attributes. Likewise, the address, street, state, postal code. Street can be further divided into street number, street name, apartment number. Okay, so the address and the name becomes the composite attribute. Alright, now let us see this ER diagram further. We are slowly putting the more and more details so that you can understand it better. Okay, now see the customer, strong entity here is connected to loan, another entity, strong entity here. Now you see the loan, I am again showing it as a strong entity here. And the borrower, customer borrows a loan. I'm putting the relationship in a single diamond. Okay, customer has the four attributes: customer ID, customer name, customer street, customer city. Customer ID becomes the most unique thing through which I can recognize the customer. So this becomes the primary key here. Okay. Likewise, the loan part, loan number and amount of these two attributes, the loan number is the most important thing through which I can work out like what is this loan details all about. Okay, who is the customer, who is the detail, everything, because they are connected. Okay. These parts we have been discussing so far, related rectangles, diamonds, lines. Okay. Lines are showing the connections between entity and attribute or between the two entities. All the lines show the connections. Okay. Double ellipse shows the multi-valued attribute. Like dashed ellipses denote derived attributes. Okay, like rather than being like amount, I'll putting dashes. Okay, all throughout the dashes will be there. I'll show it later. Okay, somewhere it is primary key attribute within the strong entity. See here, loan number. I'm putting an underline. Means it is the primary key. Remember that the primary key attribute, the most important attribute of a strong entity is like described as denoted as with an underline. Within the name, we will put an underline. Likewise here, see, so customer ID and loan number, we are putting an underline. Okay, so this becomes very simple. Okay, this is the complete part. Okay, Sorry. Now see the more detailed part. Same customer, okay, customer ID, phone number, date of birth, age. Now see the derived part. I'm putting this age in dashes. So it becomes a derived attribute. Date of birth is a strong attribute. Okay, important attribute. But phone number, I'm putting double. See the double ellipses means it is a multi-valued attribute. Customer ID is another attribute, but I'm underlining it. This becomes the primary key, primary key of the strong entity customer. Okay. Likewise, the season it has name. Customer has another attribute name, but I'm putting first name, middle name, last name. So this name is a composite attribute. I can put multiple values here. Okay. It can be taken segregated into multiple small values. All right. Now see the further address. This customer has another attribute address, which has four attributes: street, city, state, zip code. And the zip code is itself able to enough. So if I show it as primary key, it is correct. Okay, but nothing is shown here. Okay. Now see the part street can be denoted further with the street number, street name, apartment number. So the street is also a composite attribute. Alright. So like that we are putting the relationship sets. So relationship is an association between several entities. For example, a person has the customer entity has the depositor. This becomes a relationship set. A customer can be a depositor in a bank, okay, and the account entity. It has the account entity as well. Customer will have an account. It can be a depositor, can be a withdrawer. Okay, it may deposit the money or take the money. So I can have multiple entities there. Okay, the relationship set is a mathematical relation among at least two entities. Okay, like that. See the symbol here. Okay, this is the most important part. Belongs to the haze and the account number belongs to depositor. Okay, so in within the depositor part, what thing is required? This haze and account number. Even if I show the account number here, that is self enough. Account number will be properly connected to haze, so I no need to show because account number will be the primary key. We are just extending the discussion further. So within this relationship table, in the depositor part, the depositor detail will be there, but connected to the these two things, attributes, the name and the account number is shown here. But if I'm showing his account number, that's also correct, valid, no problems. Okay. So multiple entities can be connected to each other. Like that, we are building the table. As you have seen in the previous diagrams of entity relationship. But these entity relationship tables are just the tables. But when we are writing it in the some sort of equations or something, are they right or not? Just when you are checking, we normally show them this way. This belongs to this. Okay. So this epsilon symbol shows the belonging to. Okay. Like that the things works out. See an example here. Okay. I'm having five entities here. See. Seven entities. Sorry. Okay. These seven customers. Okay. E1 is connected to capital E1. E2 is connected to capital E2 and E6. Then 3 is connected to 3 here. See the 4 is if small e4 is connected to capital E4. E5 is connected to capital E5. Okay. small e6 is connected to capital E1 and capital E1, E6. And likewise, E7 is just connected to E7. So whenever you are building the connection, I'll show it as E1, small e1 belonging to capital E1. Then small e2 belonging to bracket, I'll write it as capital E2, comma, capital E6. I'll show after belonging to sign, I'll show two things, capital E2 and comma E6. Like that the things will work out. Like this. And this will go on. And E6 belongs to E1 and E6. And E7 belongs to E7. So I can show it like this in a better way. See? Rather than showing them separately, I can also show it as within the curly brackets E1 to E7 because the relationship stands true for all. So E1 to E7, then a pipe to denote the connections further. Okay, E1 to E1, E2 to E2 to E6, likewise. I can show them as all together. The last thing, so you understand that one entity can be connected to multiple entities. Okay, so if it is relationship set between only two entities, it is called binary. It is called degree. How many entities it's connected to? Okay, but if it's connected to more than one, it can have multiple entity connections as well. So normally it is two in all the diagrams. See, we are just connecting one entity with another entity. So normally it is binary. Okay, degree 2s. See, the number of connections are called as degree. Okay, that's this all about. Okay, thank you so much, and you come in all.